We're going to bring you... Well, we were down to Earth. We're going to take you up into beyond to one of the country's best-known space scientists who's appeared on our screens for more than a decade with programmes like The Sky at Night.
So we're talking about Dame Dr. Maggie Aderin-Pocock, who is now sharing her knowledge of the James Webb Space Telescope in a new book. You know, we were talking about lovely images on Earth.
These are astronomical.
These are images
Literally.
that are completely out there.
Astronomical. Yeah. That's what they are. We're going to talk to her shortly. First, take a look at how the telescope began its journey.
Maggie's with us this morning. I was questioning this morning, Maggie, you won't mind me asking, is it Dr. Dame or Dame Doctor?
I think, well, I don't know. I'm going for Dame Doctor, but
Dame
I'm
Doctor.
not sure.
And you don't mind either way, do you?
Can we call you Maggie still?
Oh, please.
Yes.
Oh, yes.
Let's do that.
Definitely.
Amazing pictures behind us here.
Oh, I love them. Especially that one's there, the Pillars of Creation.
Now, look, the Pillars of Creation, these things are given amazing names, aren't they? Because this is a star-forming region, hence the name, the Pillars of Creation. So this is... Are we seeing stars forming, Maggie?
We are, yes. So this is what we call a stellar nursery. But the thing is, the scale of it...
where all the little ones grow?
The baby stars are built. But the thing is, it's on a massive scale. Can you see that little red bit in the central column?
Is that the Higgs?
Yeah, that's where the star formation is happening. But that is maybe sort of 100 times bigger than our solar system. So these are a nebula, and this is where stars are formed. So our solar system...
Hold on, stop.
OK.
Stop. That little red bit...
Yes.
Just the little red bit...
Yes.
...is bigger than our whole solar system.
Yes.
And is this a real picture?
It is.
It's not an imagination.
Oh, no, it's real. But it's real, but it's infrared. So in the past, many people have taken this image.
So someone has coloured this in?
Oh, no, well, so the Hubble Space Telescope, for instance, took this image of this Pillars of Creation, and it's been taken a number of times. But the James Webb Space Telescope is an infrared telescope, so it picks up heat energy. And the joy of that is some things that Hubble can't see because clouds of dust stop the light getting through. With infrared, we can see through that dust and see what's happening right at the heart and how the baby stars are being formed.
I'm going to ask our director, Tim, to just bring that picture up for her. Can we see that one again, Tim? So when we look at this, as we will any second now, how much of that is solid thing?
Oh, yeah. Ooh.
Is that, you know, or what's kind of gas or dust or whatever?
And so it's mainly gas and dust, because that's how stars are formed. They're formed out of gas and dust, which all clumps together to make the new star. But the thing is, that gas and dust, because it's moving and interacting, sometimes it gives out radiation, heat energy, and that's what we're picking up with the James Webb. So that's how we see things out in space. They give out sort of light, they give out visible light, X-rays, gamma rays. That's what we pick up.
If those stars are in the nursery...
Yes.
Nursery of... What did you say?
Oh, a stellar nursery.
A stellar nursery,
yes.
Right. When do they become stars?
So in that process, what happens is things start clumping together because of gravity, and they clump and clump and clump, and bigger and bigger and bigger, and eventually what happens is you get to a critical mass. You get enough mass in the star that it actually starts this process called fusion. Fusion is when it starts smashing atoms together, and that's when it starts giving out light. So, yeah.
So, actually, if we move on to the Cartwheel Galaxy...
yes.
This takes the story on, doesn't it?
It does,
a little
yes.
bit. Because it's a cataclysmic collision between two galaxies.
Yes.
I mean, I have so many questions, and I love the way you answer our questions. One, this is beautiful.
Yes.
So 2 galaxies are colliding. Where have they collided? I know that sounds stupid, but I'm seeing a cartwheel and I'm seeing something else on the other side.
Yes, and so we have sort of 2 other galaxies, which are sort of I'm just sort of tagging along for the ride, really. But what you see in the cartwheel galaxy is that 2 galaxies. So galaxies, our galaxy is the Milky Way. It contains 300 billion stars. And every so often, what happens is galaxies will collide. And it sounds like, they say it's sort of cataclysmic, but what happens is, because stars are very widely spaced, what happens is the gravity pulls them together, and you get these wonderful swirling patterns as they come together. But that's the future for our galaxy as well.
Our galaxy is going to crash into another galaxy?
Yeah, the Andromeda galaxy in the future.
When's that going to happen?
A few billion years. We've got time to prepare.
So, again, Maggie, can I do the thing? The white bit in the centre...
Yes.
What is that?
So that's a collection of stars all giving out light, infrared light, and that's why they seem so bright.
That's a solid mass, is it?
That's solid mass. So we'll see solid. It's billions of stars all there together giving out light. And then what you can see in those arms is that as the 2 galaxies have collided, they've sort of swirled together, and you get this structure. So all those sort of filaments are stars as well.
If you'd asked me, if I'd seen that picture not knowing it was anything to do with space, I'd have thought it was a jellyfish.
Actually, it does. It looks quite like sort of the deep oceans with the colours and things like that.
Where are we going next? There's another image, isn't there?
Cepheid variables.
Oh, yes. Cepheid variables.
Cepheid, sorry.
Well, actually, there's a bit of debate into how to pronounce it, but Cepheid variables are stars which flash, and they flash depending on how bright they are. And this has been really useful in the past, because in the past, in the 1920s, we thought that we were the only galaxy, but we saw these Cepheid variables out there, and we suddenly realised the scale of the universe. Because we know how bright they are because of their flashing, we can work out how far away they are. And this is one of the things that indicated that the universe was far, far, far bigger than we ever thought possible.
Now, we could... just as we're sort of looking at these images, I know, Maggie, that one of your passions, as well as space, is learning, isn't it? In its wider kind of context, which is what you do so well, because you help us all understand things. But that's one of your passions, isn't it? That people should not be afraid to learn and, you know, not intimidated by...
No, lifelong learning, that's my key. And so, because every day you can pick up something new. I'm learning French really slowly.
How's that going? Is it going okay?
Un peu. Un petit peu. Je ne comprends pas. But
sounds pretty good to me.
But yeah, there's always something new to learn, and the universe teaches us that. We only know what 6% of the universe is made of. The other 94%, we have no idea.
How...
So I'd like to say that to kids to encourage them to come and help us.
Yeah.
I'm going to ask this question, and how long away can the telescope see? And I say long because it's measured in time, isn't it?
It is. So we talk
about...
about...
not distance.
Well, you see, it is distance, but we talk about light years.
Yeah.
And so sort of some of these objects we're looking at are sort of millions of light years away from us. And a light year is the distance that light travels in a year. So the speed of light is fast, 300 million metres per second. So, yeah, I came in from Guildford earlier. That would have been lovely.
Yeah, it would have been.
So that's how quickly light travels. And a light year is about sort of, let's say, 10 trillion kilometres. That's how far light will travel in a year. So when we say that something is sort of 10 light years away, it's taken 10 years for that light to reach us. And some of the things we're looking at here are millions of light years away, or even billions of light years away. And so by the time the light reaches us, those objects don't exist anymore.
How's your head, Charlie?
You're looking a bit
Charlie's
pained.
got that face.
No, I'm on the big learning curve thing.
Love it. Every time you come in.
Il faut dire au revoir.
Au revoir?
Il faut dire au revoir. C'est le fin.
Oh my goodness.
C'est dommage.
Oh, Sunday. Dommage?
No. It's a shame. It's a shame.
Oh.
Our time is up.
Oh.
That was very good as well. That sounded French. It's a delight seeing you. This book is amazing. The pictures are extraordinary.
Stunning. Oh. Maggie's book is called Webb's Universe, the Space Telescope Images that Reveal Our Cosmic History. And if you think you learnt something just in that chat, we all did, you will learn loads from this.
Thanks, Maggie. Time now to get the...
Go on.
Au revoir. Au revoir.
Time now to get the news, travel and weather where you are.